Nearly 2 years ago, NASA brought a sample from the Bennu asteroid to Earth. And this past week, researchers shared that the asteroid actually contains the building blocks of life. The asteroid had a briny broth, that contains salts and minerals that are key to forming life. These materials date back to the formation of the solar system, and it's the first time that these minerals and compounds were found on an extraterrestrial sample.
More than 3/4 of the sample is archived at the Johnson Space Center in Houston, also at the Japanese and soon Canadian space agencies, so that people can request samples if they have ideas that we're not examining. And in fact, people not yet born can use techniques not yet invented to answer questions we haven't even asked.
What astronomers don't know is whether these elements were able to create organic life forms. NASA's Goddard Space Flight Center in Maryland analyzes these samples. Meanwhile, Johns Hopkins Applied Physics Lab celebrating a different achievement now. The Parker Solar Probe survived a close encounter with the sun's surface. Joining us now is Dr. Noor Wafi. He is a project scientist with the Parker Solar Probe. Good to see you, sir.
Good to see you. Thank you very much for having me.
Throughout my life, people said, Mr. Newton, you're flying a little too close to the sun. You're telling me it's a good thing to fly a little too close to the sun as far as this probe goes.
It's a fascinating thing. First of all, it's extremely hard to get close to the sun. But going closest to the sun, we learn so much about it. And you know, we owe our existence to the sun. Sure. And we live on a daily basis in relation with the sun. So we better understand how this star works, that we can benefit the most from it.
And tell me the purpose, and I try to read up on it, but you're going to have to help me with the science. And it says that the surface is a bit hotter than the core of the sun. I get that correct? Solar winds is something you're looking at as well. Also some particles that can disrupt. I've always heard about solar flares. All of this research ties into this one probe, correct?
Absolutely. There are so many mysteries about our stars that scientists have been struggling with for decades now. And the solar corona that we see during a total solar eclipse, it's way, way hotter than the solar surface. Huh. It's over 300 times hotter than the solar surface.
Man.
So the surface of the sun that we see with the naked eye is at about 10,000 degrees Fahrenheit.
Okay.
You go about 1,500 miles above, and the temperature of the gas will jump to multi-million degree hot.
Wow.
It's fascinating.
So what fascinates me, and I guess it's the common question, is how in the world does this thing get close enough and you don't lose any of it? Because the human thought is, well, that thing's going to melt.
So we have been thinking about sending a probe as close as possible to the sun for over 60 years now. But obviously the technology was not there.
Okay.
NASA tried many times to implement the mission, but we did not have the right technology. In 2018, we came up with all the solutions at the Johns Hopkins Applied Physics Lab, and we came up with the right material that is a heat shield that can protect the spacecraft when it is flying closest to the sun.
Okay.
On December 24, Christmas Eve of last year, when Parker Solar Probe hit the closest approach to the sun, this side that is facing the sun was glowing at more than 1,800 degrees Fahrenheit.
Good grief.
About 1 yard behind,
yeah,
it's almost room temperature.
Really?
And that's where the main body of the spacecraft and the instruments are residing.
Holy cow. So, and then you were talking about, so tell me some of the instruments on there so folks can understand what we're looking at here. Heat shields on the back. What's on the reverse side?
So we have the heat shield on top here.
Okay.
We have this tiny instrument here, and for antennas, these are also exposed to the total environment of the sun.
Okay.
Everything else has to fit within the shadow cone of the heat shield.
Okay.
Here we have the solar panels. Obviously, they have to be exposed to the sun.
Sure.
But when we are far away from the sun, we deploy them completely close to the sun. We stow them back to the body of the spacecraft. But the instruments, you see them here and here and here. They are all operating at room temperature.
Wow.
And the shadow cone of the heat shield.
Why was it important for this vehicle to be so fast? One of the things I read was that it's probably one of the fastest that's been developed. Why was speed important?
The speed is dictated by gravity.
Okay.
So when you go around a massive body around the sun, you will get fast.
Okay.
And just to put in perspective, to put the speed of Parker Solar Probe in perspective, on Christmas Eve of last year, Parker Solar Probe was flying at more than 190 kilometers per second.
Wow,
that's a huge number per second. So you can make Philadelphia, DC in about a second.
Okay.
Which is fascinating.
Wow.
Just now that we are thinking to send humans back to the moon,
It
will take astronauts to get from the Earth to the moon about 3 to 4 days.
Okay.
If you pick a ride on Parker Solar Probe at that speed,
yeah,
you can make that distance in about half an hour.
Half an hour.
Half an hour.
That's not a ride I want to be on. NASA doesn't do anything for nothing. And so I'm guessing that what you gain from this will be used for some sort of future research. Does this help in the move towards Mars? Does this help to, or is this purely understanding?
No, absolutely.
Okay.
Let me give you one of the examples that we did. Obviously, when Parker Solar Probe is close to the sun, we cannot talk to the spacecraft.
Okay.
It has to deal with every potential issues on its own.
Okay.
It has to be 100% autonomous. The autonomy system we have on Parker Solar Probe is probably one of the most advanced ever built.
Wow.
It can drive the vehicle for up to 2 months on its own. And we did that already twice. So that autonomy system, now it's inspiring future missions. And obviously, when we are going to Mars, we need some autonomy there on the system, on board of the system itself. So, yeah, absolutely. Yeah.
I love it. Listen, there will be people who want to learn more. I'm guessing there's a website where they can sort of look things up. Where should they go if they're online? Or do you?
If they can go to parkersolarprobe.jhuapl.edu. They can go also to NASA, nasa.gov. You just Google Parker Solar Probe. You'll find plenty of information about it. And most importantly, you can learn about the amazing discoveries that we have done over the last 6 years.
I'm intrigued. I love it, sir. Thank you for coming by.
Thank you so much.
We appreciate it.
Thank you.